Well, we're going live. All right, cool. Looks like we're live. All right, hello everyone. Hello. This is Zach here, and I'm with Sarah, joined by Sarah in the One Leaf Discord. So I'll be chatting with her. If you're wondering who I'm talking to, I'm not crazy, I swear. But feel free to jump into the Discord and chat with us. You can jump into the voice channel, or you can talk in streaming discussion, or leave a message in the YouTube chat. So, for today's stream, we're gonna get an introduction into basic iOS. We're gonna make a really simple temperature converter app between Fahrenheit and Celsius. And after that, I'll talk a little bit about memory management in Swift, giving examples with UI views, because we can see them kind of be created and also be destroyed or go away or disappear. And hopefully the memory that they use also goes away. So we'll see how that works and how Xcode allows you to check the memory of the program. The last thing we'll talk about is a framework that I work on and I have called SwiftUIKit, and it's just made to make UIKit, which we're going to write, because there's SwiftUI is the newer kind of way to write iOS, macOS, watch, and tvOS apps, but that's restricted to the newest software, so like iOS 13 or Catalina and up. So this was an attempt to make UI code or UIKit easier to write, at least for the time being, until we can write more SwiftUI for production, or at least that's where my company sits. We're not looking at SwiftUI right now, so we're really continue with UIKit because our app was built in UIKit 5 years ago. So we're not gonna just change to SwiftUI and drop 30% of our user base. So that's the whole reason for that. But yeah, so that's why we'll be looking into UIKit, because I think it's still relevant. You still use UIKit in SwiftUI, but it's how you've been able to make apps for years now. So let's go into Xcode, and we will just create an Xcode project. We're going to create, this time, an iOS single view app, and we'll just go next. And you can name it whatever you want. And for this, make sure that you have Swift, and make sure that the user interface is storyboard. That will use UIKit and not SwiftUI. I'll talk about SwiftUI in another stream, but right now we're going to talk about UIKit. So let's click on storyboard and create, and we'll just put it wherever you want. I'll just throw it in my development folder. And I'll give you a little bit to catch up, Sarah. Yeah, what's up? Yes, okay, so then we're going to click on the left panel. You'll see Project Navigator is this little icon over here, or you can do Command 1 to open it, or to move through these is Command any of the numbers. But now we can click on the ViewController, and you should be where I am. All right, cool. So we're there. So, sorry. For this purpose of just showing you guys UIKit, I'm going to put all the code in this function. Normally you won't put it all in one function. You'll have some sense of structure to it. But for this case, it just simply we'll put it all in one function. So if we run the app really quick, let's just run it and see what we get. By default, we'll just have a blank white view, and that's pretty much it. So yep, just looks like that. That's cool. All right. So what we're in right now, we're in a ViewController class, and ViewControllers are what contain views, and you can think of a ViewController as a screen. So if you look at any of your apps on your iPhone, if you have one, every screen that you go to that's like a different navigation, like if you go back, or if you go into something and you move away from a screen, or if you use the tab bar at the bottom to go to your home screen or your settings, like those are all different view controllers, and they use views to show that. I got a question in the YouTube chat. Are we going to cover SwiftUI? Not in this tutorial or this video. I'll cover in another one. But yeah, sorry. But yeah, like I said before, you still use some UIKit in SwiftUI, so going into SwiftUI, it's better to know some UIKit. So yeah, view controllers contain views, so we can see that this view controller has a view, so we can say self.view, and it's the view that the controller manages. Okay, so we have a white background, so let's just change this view to blue. Oops. So now we'll just run it, and really simply it changes to blue, and quite a that hurts my eyes. So we can also add views to other views. So let's create a view, some view, and we'll just say it's a UI view, and we're gonna give it a frame, and feel free to give the frame whatever you want. I'll just put 100 for the X and 100 for the Y, and then say 200 width, and let's do 400 height and see what happens. Make sure that we change the background of this view to some anything, and I will just change it to a brown. I think that looks amazing. And now we will just add this view to our main view. So view.add_subview lets us add any UI view or anything that is a UI view, so like a label or a button, and we're able to add it to this view. So when we run it now, we'll see this kind of brown squarish view pop out in the middle. And so let me know, did you get that, Sarah? Yeah, sorry. I should probably have like the key map or like the key, there's a program that shows all the keys that you press. But, alright. Alright, I'm gonna let you finish that up, but I'm gonna move on to the next thing, because I guess for old style code, or at least when I remember like starting iOS, we did frames, and this kind of like hard coded, or I'd call like hard coded, or you could call magic numbers of what the views are. And it looks fine right here. Let's say this is what it's supposed to look like, but if I rotate my phone, rotate it. Oh, why isn't the phone rotating? Come on. Oh. Okay. What? This is ridiculous. Oh, it's the other button. Okay. Whoops. Yeah. All right. Whoops. Holding control. All right. So, but it's not in like the same place that it was. It's changed. It's kind of just stuck there. So let's say we wanted this to actually take up the whole center of this and have like some padding. All right. How do we do that? And how do we make sure it stays like that when we rotate our phone? iOS has what's called constraints or auto layout. And what we can do is we don't have to define the frame here. Once we've added a view, or in this case, this view, or some view to a view, after that, we can say that we want some constraints about this. So let's say that some view.height anchor, and we can set anchors. So there's a few different anchors. There's height and width, which we're going to experiment with right now. But then there's leading, trailing, top, and bottom. And that's kind of like top, left, right, and bottom. And you can say where that's relative to its parent or another view. So we'll show that in a sec. But here, let me show you setting the constraint of the height to a constant. And now this is ideally the exact same thing that we did before, but it just doesn't have 100, 100. What we can do is we can say that we have some constraint, and we've created a constraint. So if I alt click on this, I'll get the NS layout constraint, and I can say that it's active, and that will activate the height of 100 for this. So that's cool, but like I said, we don't want the height because it's going to kind of still do the exact same thing. We want it to be kind of embedded in this view. Okay. So what we can do is we're going to set the leading, the top, the trailing, and the bottom relative to this parent view or the super view. So I'm going to type in NS layout constraint, and I just press enter there to get that to finish. Dot active, and then we'll just give it an array of constraints that are automatically active. So all we have to give in this is that. So we don't have to do the is active for 4 things. So it's just a convenience thing. So we're going to say some view. We're going to say it's leading anchor. I know there's left anchor, but I've just used leading anchor. I don't know what left anchor does really quick. Or let's check really quick. Views frame, left edge of the views frame, leading edge of the view. All right, I'm not too sure. I'll have to check that later. But for a leading anchor, we can set the constraint equal to another layout anchor. So this one right here, it says accepts another layout anchor and a constant. So we can say that we want it to be the same as the view's leading anchor. So all that would say is that this edge right here is respective to this edge, and the constant is just how much in. So let's say 32. So this would be that this edge is going to be 32 pixels away from this edge always, and that even means right here. So this would be 32 pixels away from here. So we're going to do that for every side of here so that it's just embedded and it has padding of 32. Okay. So I'm going to type these out, and I'm just going to comma, and then I'll just copy this and paste it 4 times. And all I'm going to do is change this to trailing, top, and bottom. Okay. And so for the trailing and the bottom, we want these negative. And that's just because we don't want to add more to them, and we don't want to push them past here, because adding 32 to a trailing anchor is over here. It would be like where my mouse is right now, over to the right of it. And we want it over to the left. Oh, that's really interesting. Thank you, Justin, for saying that leading versus left can depend on the device's language. I'm gonna have to look into that, because yeah, I always just like to be informed of what things do what. Yeah, I've never used that. I've never heard of it. So thank you for calling that out. But like I said, I'll have to look into it more, and I'll bring it back up in next stream if I remember. So now, if we run it, nothing shows up. And the console will output a lot of things and say it will attempt by breaking a constraint. Okay, well that's not good. We know what our constraints do. So every view by default comes or has tamic equals true. So we want it to be false. So by default, all the views translate their auto-resizing masks, which you can say how they kind of scale with stuff. It's a different way of constraints, but we don't want them to set up constraints because they just translate auto-resizing mask into constraints, and then we have constraints fighting constraints. So to just not make the system add any constraints, we'll just turn that to false. Okay, so then the only constraints added to this view are the constraints that we've added right here. Okay, so let's run it again after we've added the false flag, and this is commonly known as tamic, T-A-M-I-C. And you can see right here, now we have everything kind of with a padding of 32. Okay? All right, so let's change this up a bit. I'm going to make this a little bit different. We'll just make the padding a lot more. I can't type. Okay, so let's say I wanted to add a border around this view really quick. How would I do that? Okay, so I can do some view, and every view contains a CA layer or a layer that you can draw on for borders or other shapes and other things. So you can think of a view contains multiple views or subviews, and a layer can contain multiple layers or sublayers. So they're very similar. So you can have a view that has multiple views, and all of those can have multiple sublayers or multiple views. So yep, we can just say layer to access the views layer. So since every view has a layer, we can just say that. And all we want is border width of, let's say, 1. And then let's also say that we want the border color, let's say dark gray. And so we can't do the dot because the compiler can't infer the type. And it can infer the type here because this is UI color. And if I type in UI color dot white, or blue, or all these, they're already here, so it can infer that I want white. But this border color is asking for a CG color. It says right here. So what we have to do is just say UI color, and then dark gray, and then we just say CG color. Sadly, we can't just access CG colors. We have to turn our UI color into a CG color. Okay. And now let's do one more thing, and let's say some view dot, I think it's layer again, corner radius, and we want a corner radius of 8. Okay. All right, let's run this. I think that looks good. What we'll do now is just add a text field, and we'll add a button and have it just be a temperature converter. And then I guess that's kind of where we'll end this really small introduction into iOS. So we have some view, and we've added the view, and now we just need to add the views to this view. Okay, so let's just pretend that. All right, so let's add some view to manage these views. Okay, we can add all the views manually, so we're going to add a button, and we're going to add a text field, and we could place those in here, or what we can do is have a stack view. And a stack view allows us to just put in some views into the stack view, and it will manage those for us. So we can say arrange subviews. Well, we won't have any, but for this stack view, we want it to be vertical. Oops. So not distribution, axis. Okay, so it's going to be vertical, And let's see that. All right. So then we'll just say some view dot add subview stack view. All right. There we go. Oops. Should I hit the mic there? So now we need to add. Well, I mean, if we run it, we wouldn't see the stack view. There's no views inside of it. But just knowing this, we need to set the constraints of the stack view. And again, we need to remember stackView.tamic, and tamic equals false. Okay. So now we can steal this really quick and really just change some view to stack view. I always like the one that I'm constraining the embedded one inside on the left, and then whatever the parent is on here. But I mean, you can switch them or whatever. I think they're respective. So this view would know that it has a constraint on here, and that stuff. They're bound, so they know. And so here we're gonna put a constant of 0, just so we don't have to deal with that. And so now let's add some views in the stack view. So you can imagine that if we have some views, they'll just start stacking up vertically right here. So let's add a button quick. And we can just say button equals UI button. And we'll just say the title is a, well, I was going to say click me, but convert. Let's just say that, and we'll just say normal for the state of that. All right. And now what happens when we click this button? Well, we need to add a target, and the target is just the object kind of managing the state of, I forget the actual terminology. Here, let me, before I butcher it. The target object is the object whose action method is called. Okay, yeah. So this is the action. So we are going to supply the action, and the selector, is just, I can't type, is just the method that we're going to use, or the method that's supplied to act as this button's action. So we'll just say button tapped, and we just want to say touch up inside. So once they release their finger on the inside of this button, we'll do that. So we'll get an error right now because we don't actually have button tapped. So we're going to scroll down and make sure that we have, or make sure that we put this function inside of ViewController. So don't put it on the outside of this curly brace. And we'll say at Objective-C function, the name, and now we just kind of define the function. The reason we have to do Objective-C is just because this is tied in to Objective-C, kind of the old way of how a selector works. It's I guess not a topic I want to get into for Swift, an intro to Swift, because it's not really anything that aligns with Swift. It's more of how Objective-C managed it, and that's why we had the flag. So anytime they tap on a button, or tap on the button, we just say hello world. All right. Okay. So all we need to do is add this button to the stack view, and let's run it and see if we see this button show up somewhere on this view. Awesome. I don't see it. And that's maybe, I forget if a button's default white text, or is it just not showing up for another reason. Hey, what's up? Sorry. Yeah. All right, there you go. All All right, Sarah's yelling at me because I'm typing too fast and scrolling everywhere. Sorry. But now we have the button, and every time I click on it, it'll say hello world. All right. I'll wait a little for Sarah to catch up. Okay, so now what we want to start thinking about and doing is, I don't think I'm going to make a text field just because that's going into delegates, and I want to talk about that in the next topic when I'm talking more about table views and delegates and data sources and kind of managing that. But for this, let's put in a label and let's give some temperature in either Fahrenheit or Celsius, and let's just make this button switch between those two. Okay. So I'm just going to put the label right above button. It doesn't really matter. Like I said, you're not going to really want to put all of your code inside one function, so this is not a practice that you'd want to keep or do. So we can just say label and say, well, first off, I'm going to scroll a bit up. Let's give this ViewController some temperature, and let's just say it's 32 degrees Fahrenheit right there, and we'll have a boolean that says is we'll just go there and we'll just say true. So is Fahrenheit, it's true, and the temperature is that. Okay, so we're going to put our label dot text equals okay, we'll say that, and is Fahrenheit. If it's Fahrenheit, we'll put an F, and if it's Celsius, we'll put a C. All right. Okay. So, and I can even make just a calculated variable to always give that to me. So now I can just do, I can just do temp. So I can get the temperature really quick, which will give me that. So let's just do this. So I've only added 2 lines of this, and I'm just going to add the label to the stack view on this button. And there you go. I get 32 Fahrenheit right there, and it shows up with the text. All right, that's awesome. Okay. So for the button now, we want to switch some temperature from Fahrenheit to Celsius, or really we'll just switch is Fahrenheit and we'll toggle this. So we're going to switch Fahrenheit to Celsius and toggle the boolean. Okay. All right. So then all we have to do is that the label's changing, so we should save a reference to the label outside so that we can change it when it updates. Okay. So we still get a reference to label in here. It can reference it here, and it just changes color because now it has a different scope than button. Button we can't reference after this after this function's done, but label we can reference whenever. Okay. So now anytime that some temperature, whoops, can't do that. anytime some temperature changes, or we just we do a setter on it, so we can do anything after it did set or it was changed. So once some temperature changed, we just want to update the labels text with temp. Okay. So anytime Fahrenheit's changed, we'll just update some temp. We'll check if is f else, and I'm just doing this really simple to make it an easy example. I'm not saying that you should do this because I don't think this is good at all, but just to make it really quick so we can click it and everything changes, we'll change some temp. So if this changed and it switched to Fahrenheit, we would assume that some temperature is Celsius. So then we'd need to just change it into Fahrenheit. So for that, yeah, I'm already getting confused by this logic because it's weird and I don't like this, but okay, yeah. So is Fahrenheit, then we will times this by 1.8. Sorry, I'm looking at a cheat sheet. I don't memorize this by my head. I'm 32. All right. Otherwise, it'd be minus 32. Okay, and I'm not supposed to return. I don't know why I put that. Oh. Sorry, I'm confusing everyone probably. It's just, what am I doing? Alright. We'll just do that. So, if I run it, when I click convert, I would expect convert will toggle is Fahrenheit or is F, and that would then cause this to run, and it's true at first, so then it'll go false, so then it'll turn some temperature into Celsius, and that'll change this. So yep. Oh, and now it broke. Yeah. What went wrong? 1 second. Let's run that again really quick. So it's true, it's Fahrenheit. We click convert, it goes to false, it goes to here. Boom. Alright, and then we click it again. And oh. Wait, no, it should go over here. What? Yeah, what? Why that? Oh no, I don't want to debug this on the spot. This is supposed to be a simple example. Whatever. Sorry. Oh, temp equals. Oh yeah, okay, thank you. Yep, sorry, chat's got me. See, the only reason I do this live is so you guys can correct me. Thank you. Alright, there we go. Oh my goodness, chat's saving me. Alright, so then let's say it's nice out. It's 372. No, sorry. Let's say it's just 72. So I live in the US, so I'm not a big Celsius fan, but let's find out what that is, and that's a very cool number. So I hope that's correct. Maybe chat can correct me, or maybe I can Google it really quick. But I think that's correct. So Okay, that's awesome. So what I was saying before is after this quick example, I'd like to show you some of Swift's memory management capabilities. And it's kind of shared between Swift and also Objective-C because they introduced it, I forget when, and don't quote me, but I know they have the same memory model, and it's called ARC, or Automatic Reference Counting. And it's how views in iOS are managed or deallocated, or how they stay in memory. So you can see our memory that we have over here, and we have a nice little button, and this is our debug memory graph. So what we can do is we can click this button, and it'll show us all the memory and all of the allocations, or the view controller, the views being used, and everything like that. So let's do that really quick. And we should expect a view controller, a view, some view, and then a stack view, and then this label, and then the button. So let's kind of look for that. So I do see a view controller right here. So we see that in memory. Don't see anything else. Maybe the I guess the views are, yeah, right. It's just showing there. Go inside. Whatever. But yeah, you can see that we have a view controller, and yes, it shows us that. Don't know why we're not seeing the views. I guess because they're not. Oh yeah. Okay, because there's no real reference to them. All right, so that's fine. If we had I'll show you an example of that. But let's take this and I'm gonna keep this, but I want to show a specific example of this. Did load. Okay. So I'm going to also write some comments out here to kind of illustrate what I'm talking about. So with automatic, so for automatic reference counting, there's 3 different types of methods, or I guess classifications of this counting. I don't know how best to say it, but there's I guess linking or a reference. So this is talking about the reference, what kind of reference it is. So there's 3 different types of references. You can have a strong reference, you can have a weak reference, or you can have an unknown reference. A strong reference means that you depend on this, you need this, and you're not going to deallocate, or that's not going to deallocate, because you're both a strong reference to each other. You're both using each other. A weak reference means it doesn't really count. So I guess let's first say that a strong reference counts as 1. So in ARC, if I have a strong reference, it would count as 1 when I'm counting those. A weak and unowned are both 0. Okay? So the only thing that something can stay around in memory is if it has strong references. And those strong references will keep it in memory. Once something gets 0 strong references, then it will be deallocated, or the D in it will be called. Okay? So there's 2 main types of things that can be or that are references. And if you know computer science and you've been asking the question, what's a class versus what's a struct, you're on the right trail. And classes are a reference type. So they can there can be a strong reference to a class. And then also I think we talked a little about closures. So classes and closures, those are the 2 first-class citizens in Swift, and they abide by ARC and the automatic reference counting. A struct is a value type, and it doesn't have a reference. Once you have the struct, you have the value of it, and you're changing the value. You're not changing the reference of it. A class, if you're given a class, you're manipulating the reference of that. You don't have a value, and you're not changing it. You have the address, and you're changing your reference of that. So that's the strong strong, weak, and unowned reference, and why structs won't have it, because when you have it, you're mutating the whole value, and you're mutating your value. If someone else has the same variable, if I have struct A and I pass it into a function and that function mutates it, well, that function will either have to tell me it mutates it, or it just keeps it on its own and doesn't affect me. So with ARC, we have strong, weak, and unowned. Okay. So do you have any questions about that, Sarah, or does chat have any questions? I don't want to go too fast through this, because this is like what you always have to go back to, is you're really looking for strong references, because that's the only thing that things can stay around in memory. I'm trying to think of a metaphor. That's tough. I can think of like little examples that might illustrate it. But let's do. Struct versus classes. Okay. That's tough. Yeah. So a class, when you create a class, really, the difference is that a class has an address or a reference, and the struct is just the value. Like if I have an int and I pass you a variable that's an int, and you change that int, you're changing that variable. If you had a class, though, and you did the same thing, and I gave you a class, and it's a reference type, and you change that class, well, you're changing what I have too, because they're bound by a reference. They're all at the same address. I could give you like an actual code example of showing you, like, I create a class A, and I create a struct B, and I, create let A equals A, and let B equals B, and I create these, and let's say I pass them into some function, and it takes in A, and this function, times A by, like 2. Inside of this function, inside of here, A would be, A times 2. I know this might be a bad example. I hate examples. And if I change this A, it's going to actually change this value. But if I pass in B, and B's a struct, well, it's not going to. I'll touch on this example a lot more, because I know a lot more people have questions, and I don't want to just quickly try to explain it, because it's like a fundamental understanding of that. But know that when we're talking about ARC and references, we're mainly talking about classes and closures. So we have a question. What's the difference between weak and unowned? So weak and unowned are really just optionals. I mean, you can really think of all three of these as different versions of optionals, and strong being not an optional. We always have a value. We always have one. Weak and unowned are both optionals. Weak is an optional, and unowned is an explicitly unwrapped optional. So when you do use weak, and let's say I have let some closure equals something, and let's say I say self.view is blue. Dot background color equals dot green. All right. Okay. So what I can do is I can run this closure, and it will give me green. All right. If I don't run this closure, I don't get green. But the thing is, we have a class and we have a closure. And inside this closure, we say self. So we're referencing a class. So because I explicitly say weak self in, and now I act as though self is optional. So all I have to do is this, okay? All right, well, let's say I don't want self to be optional, but I still want it not to have a reference. I can change that to unowned, and, oops, oh my goodness. And now I don't need the optional because it's an explicitly unwrapped optional. It still has a reference count of 0. I prefer weak just because I like to deal with optionals, and I'm not the biggest fan of explicitly unwrapped optionals. So you'll see most of my code has weak. But that means that at any point, this view might be nil. So this before was actually kind of really important code. Self is not optional, so self can't be nil. Oh, sorry. Am I disconnecting a little? I'll just repeat that. Sorry. So self in this case is not optional. You sound like a robot too. Just leave Discord really quick. Yeah. I don't know what I sound like in YouTube, but yeah, Discord's not being good. Wow. Yeah, it's being really bad. Okay, well, it looks like I might have to not go on Discord. Okay, so we're going to continue on, and we lost Sarah. But, so now we have a strong reference to, I'm going to check the stream really quick. Please comment if the stream's not that good or anything. I can't tell. So moving on, self in this case is a non-optional. If I alt click on it, oh, it's not showing me, but it's not optional. So that's why it's a strong reference. Self always has to be around because I rely on it. And so that's why if we make it weak, at that point self can, or ViewController can deallocate, and that this closure will deallocate. Okay, thank you. Yeah, I guess Discord's just having a lot of problems. All right, looks like I'm back in here, Sarah. Hello. Yeah, sorry, Discord was really having issues connecting. But yeah, that's the basics of ARC and everything like that. So really quick, I'm going to pivot to the last part that I want to talk about. Unless there's any questions, feel free to ask any questions while I pivot to this. But the last topic I'd like to talk about is SwiftUIKit. It's a framework I've been working on to try to make UIKit easier and to make writing old UIKit code a little bit cleaner and more like SwiftUI. I have been messing with it in SwiftUI and using it, so it can work with SwiftUI, but it's meant for writing UIKit and meant to make it a lot nicer than, all of this kind of code, and I'm going to clean it up. But I'm going to really quickly write this exact same stuff in SwiftUIKit, and we'll see how many lines shorter it is. So run that. That works. Cool. All right. So really quick, we're going to create a new project. Same thing, new. Storyboard. Come on, computer. All right. So what's going to be different for this one is we're going to go to Swift packages, and we're going to add a package dependency. Okay. We will add my GitHub link, so I'm going to put that in the chat. We'll put in this GitHub repo URL, and we're just going to go off of develop because I have some good changes in there. Not that we're going to really go over there, but I'm just used to that. So going in, we have SwiftUIKit, it's imported, everything's good. So now we can go in here and get rid of that. And all we have to do now is just import SwiftUIKit. It's there. Xcode's just slow. Stop, I see it right here. Okay, cool. So let that build really quick. Well, here, let's not look at the old code. I don't want to look at that. So let's write this really quick. So with SwiftUIKit, we can really quickly do everything that we did before, pretty much almost the exact same code in the background, but we can write cleaner code just using SwiftUIKit. So let's take our view that we have, that we were putting our other view in before, and let's do let's embed another view. Okay. So we'll say we want to embed, and I'll show you the signature so you know what we're calling. We're calling a function that accepts a closure that returns a view. Okay. So I'm going to say with padding 32, and then we'll just say our closure returns vertical, or I guess in this case it was a UI view. Let me just double check really quick. Yeah, so we just did one view with a border width and a corner radius. Okay, so we'll just do some view with a background color of white. And I think it's already default white, but whatever. All right, so then we add that. Now, I mean, we really won't see anything in here, but let's just run it. And okay, that's cool. That looks great. So now we'll just add border width. That's 3, and then border color. Black. All right, I think it was dark gray. And then corner radius 8. All right. So in SwiftUIKit, we have modifiers to quickly just change all these. So I'm still creating an object on one line. I don't have to create an object, save a reference, and then modify that reference. I can just do this super quick. So there we'll get that. Well, let's run it. All right, and so now we get this kind of view that we were expecting. It's a little bit different than the other one because, sorry for scrolling really fast, we don't have the 64, so we can change that. So just to get it closer, 64. All right, so now there's a vertical stack inside, or I mean there's a UI stack view inside of this view. So in SwiftUIKit and SwiftUI, there's vertical stacks which can align these. So again, we're just going to take an array of views that we put in here, and the first one was just a label. So we'll say some temp because you know we don't have it right now, and then we're just going to make a button. So we just had a button down there. So in SwiftUIKit, I can just type in the button name, convert, and first it said you know, hello world, so we'll do the same thing, and all we have to do is just do a closure instead of a function and a selector. It does all that in the background for us. So we can just run this, and there we go. All right, cool. So we're already pretty close to it. Let's just add, or let's just steal these, because we're trying to do the same logic, just different views. Right, so got that. So then, yeah, we need to save the label. So we'll just say that label equals all right. So we have the label, and then now since we saved a reference to it, we can modify it whenever. So there we go. Okay. Oh, and yeah, we just have to say self.label. So the button will just do what we did before, self.f or is f.toggle. All right, and now we can run it. And yeah, so it started at 0, 0 right here, and that's because it should actually start at some temperature. Whoops. Oh, it should actually be just temp. Sorry. Yep. There we go. So this is probably going to be a lazy var. The reason it's lazy is because it's reliant on self. So we need to initialize self first before we can initialize this label. If we didn't put self and we just use, you know, some text that didn't rely on something inside of here, then we don't need lazy. But we want to initialize label after everything else is initialized so that we can get self's temperature value. So we have 72. So boom, right there. Okay. So this was annoying me at the beginning. It was like, this doesn't have padding. So there's multiple ways that we can do it in SwiftUIKit. We can say the view that's embedding these views, we can say with padding, and then we can say like 16. So we'll just do that, and hopefully now the label won't be hugging up against there. All right, cool. And I could, you know, chain it. I could call it here. It passes itself after you changed it, so it doesn't really matter. But to initialize it and then just have it right there, it's better to just do it in initializers, because I only want to do it once. But now it's centered. Awesome. Okay. So let's try to look side by side with these. And if you guys have any questions, I'm going to collapse these top values because they're the same for both. Okay, here we go. So this is, on the left is normal, good old UIKit, and on the right is SwiftUIKit. Now this ideally does the same things here. If you command click on embed and jump to the definition and go to this embed, you'll see that it's still doing the same stuff that we did before, but it just hides it. Every view that's embedded does tamic, so we don't have to do that for every view. And it just makes it a little bit easier to change things that we quickly want to change. Like button, it's actually not initialized with a label. So, I mean, that's for good reason. I mean, maybe you want an image button, but for this one, I mean, you can quickly put that and just wrap custom text. I could have a button that is just a text or a title right here, or I could have a button that is, you know, some action and then anything. It could be image or anything like that. So I could quickly wrap something in a button. So this was just a really simple example of UIKit, learning UIKit, but then understanding what you can do with Swift and UIKit, and understanding like this kind of code is really popular, and it's kind of the basis of SwiftUI. So we'll see a lot more of this kind of component or declarative nature of coding UI. And hopefully this is easier to understand. Hopefully you can look at this code and understand what the UI looks better than this. I can't understand at all what anything looks like because it's just, you know, lines of code. But this, I can at least see that, you know, there's some structure. So, you know, something's embedded in something, and then something's embedded in something. And then we have a vertical stack, which just lists these versus, oh, here's the vertical stack, and then, oh, the vertical stack's added to this subview. This code's kind of weird because what about if I did, or I guess button dot add subview stack. Like, just that I can write that is kind of weird. Like, I could save a reference and do it, but it would be a little bit weirder to do it in here. But that's ideally how SwiftUI handles it. It says, like, give me, what belongs inside of me, and I'll manage it. But this is declarative, or wait. This is I'm forgetting. Oh, no, declarative versus imperative. Oh, I don't want to say it wrong on stream, and then probably chat's going to correct me, but I'm blanking on the spot. So this is declarative, and this is imperative. And now I'm going to Google it. Yeah, I totally forget because it's been a while. I don't like writing like this at all, so I've been more closer to SwiftUI and everything. Yeah, so this is declarative, and yeah, this is imperative. So sorry for the mix-up. Yeah. So are there any questions? Anything like that? Otherwise, I'll just end it. Again, feel free to join the One Leaf Discord. The link's in the description. You can always join the Discord and ask any questions. But yeah, if there's no questions on that, and then I'll guess that. All right, awesome. Well, thanks again for watching, everyone. If you did have any questions and I cut you off or anything, feel free to message me in the Discord. I'd love to talk about it or answer any questions you have. But have a nice day.